Today on BRStv Investigates, do secondary calcium reactor chambers really scrub off excess CO2 and elevate pH? Hi, I'm Randy, a host for the YouTube series BRStv Investigates, where we take popular reefing theories, methods, questions, and products and dive even further than what the manuals and packaging will tell you in order to put them to the test in real-world environments, rate them on our scale of reef fantasy to reef certainty, and then share with you, the reefing community, what we find. Today we seek to answer two questions. First, will secondary calcium reactor chambers intended to off-gas excess CO2 really result in higher pH effluent and, related to that, higher pH for the tank? Meaning, every calcium reactor has a primary chamber that recirculates CO2 and melts the calcium reactor media. However, some reactors have a second chamber of media designed to scrub excess CO2 in the solution before it gets to the reef tank, and we want to know if they really work. The second question we'll answer today is, will the secondary chamber increase the potency of the calcium reactor's effluent being dosed? Which means we'll be testing the alkalinity before and after the secondary chamber to see if there's any differences. Alright, so why should this matter to reefers and their tanks? For some reefers using calcium reactors, it's not uncommon to see the regular pH swings of their display tank fall slightly after dosing the low pH of the calcium reactor effluent regularly. Along with that, there may be additional benefits from having more CO2 contact time with more media outside of simply scrubbing off excess. For example, if we find that not only does pH go up after the secondary chamber, but also our alkalinity increases from more contact time, then some might consider that a win-win. To that effect, we plan to test today's question using a Vertex calcium reactor filled with two little fishies reborn media set to two common pH set points of 6.4 and 6.8, which represent the lower and upper pH set points that most reefers use, with flow rates of 20, 60, and 100 mils per minute, and watch for any impact the contact time may have on changes in pH between the primary and secondary reactor chambers. Since the solution inside the reactor is recirculating, we'll use the pH set points as the measure of pH before the secondary chamber, and to test the pH after the secondary chamber, we'll use this inline pH probe setup on the effluent line with a pinpoint pH monitor. Each of these points are using the BRS dual junction lab grade pH probes. We also plan to test for any changes to alkalinity before and after the secondary chamber, so I've rigged up a three-way ball valve before the chamber to draw a sample of solution directly from the main recirculating chamber to check the alkalinity before it gets to the secondary scrubbing chamber. Okay, so let's look at the results from a couple of different viewpoints. First, we'll see if there was any change to the pH from the set points of 6.4 and 6.8 after the secondary chamber, and at different flow rates of 20, 60, and 100 mils per minute. Starting with the data of the pH set point at 6.4, which is likely on the lower end of what most reefers typically choose. At 20 mils per minute after the secondary chamber, we see a slight pH increase of 0.07 to 6.47. And I'll save you the suspense, the same 0.07 pH increase remained constant for all 3 points, even when the flow rates were increased by 3 and 5 times at 60 and 100 mils per minute. For the second pH test point, we chose 6.8 for a reference and monitored the pH after the secondary chamber, where we found again a slight increase at 20 mils per minute flow rate from 6.8 in the main recirculating chamber to 6.85 after the secondary chamber. With the flow rate cranked up to 60 mils per minute, we gain another 1/100th of its pH point to 6.86, and at 100 mils per minute, we reach a pH of 6.87. So what we're seeing here probably doesn't seem like much increase at all, but for some of those reefers' tanks that have pH hovering right around that upper end of 7.9 when running a calcium reactor, adding a secondary chamber might be what gets you to 8.0. So after testing pH before and after the secondary chamber, we also thought it would be interesting to see if there were any changes to the alkalinity concentration in between the two chambers, and actually I was pretty surprised at the results. Starting with the 6.4 pH set point at 20 mils per minute flow rate before the secondary chamber, we saw an alkalinity of 35.4 DKH. However, after it traveled through the small secondary chamber filled with the same media, we see that it gained about 8.2 total DKH for 43.6. When we increase the flow rate to 60 mils per minute, we still see an increase in saturation, just less dramatic, from 35.6 to 39 DKH for a 3 DKH total increase. And at 100 mils per minute, an even less pronounced increase from 32.8 DKH before the secondary chamber to 34.6 after. Meaning that for all three flow rates combined, there is a total average increase of DKH from the first chamber to the second that is about 13% more concentrated. So as we can see here, it seems that the longer contact time the calcium reactor solution has in the secondary chamber, the more it continues to dissolve media, and thusly, we see an increase in total max saturation. As the flow rates increase, meaning less contact time, those saturation levels move closer together. Moving on to the 6.8 pH set point with the same flow rates, we see that at 20 mils per minute, we have an average of 21.6 DKH before the secondary chamber, followed by a slight increase to 23.2 after the additional contact time for a full change of 1.6 DKH. At 60 mils per minute flow, that change falls to 1.1 DKH increase, where we had 20.4 DKH prior and 21.5 after. At 100 mils per minute, again, the increase is less dramatic, from 17.8 to 18.7 DKH for a less than a single DKH point increase. The total change to concentration across all three flow rates at this pH point was a total increase of about 6%, so all in all, the increase in alkalinity was less pronounced at a higher pH set point. So to answer today's question of will the secondary calcium reactor chambers intended to off-gas excess CO2 really result in higher pH effluent, I'm giving this one a 4 on the REEF fantasy scale. Although there was a slight increase in pH from the main chamber to the secondary chamber, it really wasn't as impactful as some may thought it would have been. Perhaps small changes in pH below 1/10 of a point may help a small group of reefers who are looking for incremental changes, such as from 7.95 to 8.0, but in the long run, I think those who are using a calcium reactor and struggling with low tank pH to begin with would likely see ways to increase that effluent pH by larger margins than hundredths of a point. As for the second question of is there any difference in max saturation between the main chamber and the secondary chamber? In today's testing, we found a significant increase in alkalinity potency after the secondary chamber at lower pHs and lower flow rates, which has less of an impact as you increase both pH and flow. So what can we take away from today's testing data? Again, in those cases where you're trying to edge out a small increase in your tank pH, where your display might be on the verge of being too low, or if you're on the upper ends of a pH point and are looking to gain a little edge, you could add on a secondary chamber and make a small impact. However, for those who are looking for more significant changes to pH by more than a single tenth of a point, like from 7.7 to 8.0 or higher, you'll likely be better served looking at other ways to increase your tank's overall pH, such as better ventilation or opening a window in the room, supplementing your ATO with kalkwasser, adding a refugium, or even adding a CO2 scrubber setup to your skimmer. For those reefers looking to optimize their max saturation levels of calcium reactor effluent, adding on a secondary chamber will do that, most notably when running the reactor at a lower pH and lower flow rate. What's next in our BRStv Investigates for calcium reactors? Well, we definitely want to explore some other approaches to increasing the effluent pH, so we'd love to hear your ideas for things to test in that regard. But before we do that, we thought we'd test the max saturation levels of a couple of other popular calcium reactor media types with Carib Sea Arm coarse media and Brightwell's Coral Azarius high purity reactor media. My personal guess is that they will end up being relatively similar, but they are very clearly different types of media than the Two Little Fishies Reborn we've been using, so we'll have to test to know for sure. Thanks for watching this BRStv Investigates. Click the top link to see our initial max saturation test with Two Little Fishies Reborn media, or the bottom video for a how-to on switching to a calcium reactor from two-part. Being a preferred reefer has perks like weekly $500 order and wishlist giveaways, so click that link in the lower left to sign up, and we'll see you on the next BRStv Investigates.